Chapter 2, Section 1.6, Part 3's video. In this section, we'll continue looking at linear regressions in terms of different contextual problems. Ecologists track deer that were born in 1997. The number of deer living in a subsequent year is recorded in the table. Use a calculator or computer to find the least squares regression, which is linear regression, where independent variable denotes the number t of years t after 1997. Enter the equation in the line below. First thing you need to always know and understand is when you're dealing with time, this little statement, t years after 1997, means that you're going to reset the clock. So 1997 will become year 0 in the beginning. 98 is 1 year from there. 99 is 2 years. 3, 4, 5, 6, 7, and 8. Now, you can perform the regression, and then we'll look at what is correlation regression or correlation coefficient of the regression line. So, first things first, let's go, and before we type any of this in, let's show you how to turn on your regression. Okay. All right. So, second catalog. And you're just going to scroll down. You got to go to the D's, and what you're wanting to turn on is a diagnostic. Okay, so you want to highlight diagnostic on, hit enter, and then hit enter again. Boom. That will give you your R and R squared. R is correlation coefficient. Okay, so that's what we need in order to do to answer part of this problem. Now, we're going to do a linear regression. So first thing that we do is second plus number 4, which is clear off our list. Anything that's in there in our L1 and L2 will be cleared out. We don't have to type it over. Okay. Now, let's go to stat and enter. And if you remember, we went 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So 0, enter, 1, enter, 3, enter, 4, enter, 5, enter, 6, enter, 7, enter, and 8. Enter. And yes, I just typed that. I got to redo it. So that's 4, enter, enter, 5, enter, 6, enter, 7, enter. I don't want to take it. 8, enter. All right, so double check. Just kind of make sure what you got is correct. Yep. Now let's go put my Y's in. So the first one is going to be 170. Second one's 168. Third one's 153. 122. 93. 68. 53. 45. Okay, that's my problem. 68, enter, 53, enter, 45, enter, and last one is 29. So just kind of make sure that you've got your corresponding X and Y, your order pairs, and they're typed in correctly. All right, so we're going to go stat, arrow to the right. We're going to go down to number 4, or we can just hit number 4. Wow, that just overrode that. So the second one will give me back L1, okay? We are going to store it just to kind of get in the habit of storing. So that's bars, arrow, enter, enter, and then calculate. All right, so negative 19.783 and 179.24. So let's do this. All right, let's go. There. Okay, so that's pretty cool. Alright, so here's everything I need. So that's negative 19.7 83 T plus 79.244. Now I went to 3 decimal places, and I'm not sure if they said where to go, how many decimal places, and they didn't. So 2 or 3 should be good. What is correlation? Negative 0.986. Okay, and that's the 3 decimal places. So if that's going to 3, we might as well make sure that these are going to 3. They could have said that, but anyway, so there. So that's how you do that one. Now let's go to the next one. Well, I've got to answer some problems about that. Interpret the slope, vertical intercept, and the horizontal intercept of the line. Make one of the statements. Match one of the statements which best. Okay, the slope means it's definitely not that. So it's not how many years until 170 deer. No, the total number of deer which have died between 1997 and no. Yeah. I'm going to say F. On average, the number of deer. Vertical is C. Let's see what it had. No, didn't do that. I sure as heck didn't do that. So, I would say E for slope. F, the thing that's throwing me between E and F is by what percent on, and then on average, the number of deer that die each year. I like E, but it could be F just because if they saying that the percent goes with an exponential, and it's all verbiage, so it's either E or F. I'll guarantee that. Okay, I'm saying E. Horizontal intercept is well, let's go back and look at something. No, that ain't 29,205. That's not the horizontal. My Y's not 0, so how many deer, how many years until all died? Nope. Total number of deer which have died between 1999. No. G. I don't. The horizontal intercept would be when what year there are no more deer, right? So yeah, 29 deer are still alive in 2005, but that's not a horizontal intercept, meaning an x-intercept. Okay, so all right. Okay, the table below gives the data on hand strength collected from college freshmen using the GripMaster. Yay. The preferred row gives the hand strength of each student's preferred hand. Oh, okay. Preferred, non-preferred. Use a calculator where the independent is the grip strength of the preferred. So X is your preferred and Y is your non-preferred. So use at least 4 decimal places in any constants in your answer. Okay. Okay. So let me take a picture of this and I can start putting this stuff in. Yeah. Okay. So let's do this. We're going to need to go to 4 decimal places, so we go here. Okay, there, and we're going to hit clear. So I'm going to show you how to do that. I'm going to hit mode, and then we'll go down and go over to 4, and then we'll hit enter, and it changes it to 4 decimal places. Okay, so second mode gets you out of the screen. We're going to do a linear regression, so we need to clear our L list and L2. So second plus, number 4, enter. Okay, I'm going to hit clear again to get that out of the way. Stat, edit. Now we're just going to type numbers in, guys. So we're going to type top one's 45, enter. 40, enter. 32, enter. Oh man, this is my mistake. Got to make sure that you are in L1 putting your X's. Sorry. 45, enter. 40, enter. 32, enter. 49, enter. 53, enter. 52, enter. 26, enter. 39, 27, 27, 28, 25, 30, 52, 54, 20, 28, 2. Alright, so if, look at me. 28, enter, 32. Alright, so if I've typed this correctly, it should give me what I need. It'll match up all accordingly. So the first one's 44, 37, 26, 37, 45, 49, 19, 34, 40, 27, 45, 21, 26, 25, 29, 49, 48, 19, 22. I've done it again right there. 19, 22, enter, and last but not least, should be a 30. There. Okay, so double check, make sure all that's typed in. Okay, so we're going to hit stat, arrow to the right, number 4, enter, and we're going down to store regression, so because we've got to do some analysis on this. So vars, arrow, enter. If you're using 83, just remember L1, L2, Y1, right? You got after the regression thing pops up, type that in. That ensures that you pull in your X and Y's from your correct list and you're storing it in Y1. See, I think the first video I go over that. So, all right, so calculate, boom. All right, so here's my stuff. Let's do that like this, and then we'll voila. Okay, so I don't want that. All right, so here's my equation. 0.8746x plus 0.0213. Does it ask me for correlation? Nope. It doesn't. Okay, but it does give me, it's going to probably ask me input and output. Okay, so let's kind of look at that. What would the predicted grip strength in the non-preferred hand be for a student with a preferred hand strength of 36? So guys, this is an X equals 36, Y equals what? Okay, round to the nearest whole number. So what we're going to do is just put 36 in for X. So we got this in Y1, right? There it is in Y1. So I can go real quick. I can go to table set. let me show you this. This is pretty cool. So just in case, yeah, it's 36. Okay, good. So if you got the equation in Y1, you ever want to be able to evaluate something really quick, not have to worry about anything. So vars, arrow, enter, put a parentheses, 36, close parentheses, and what that does is it brings up the Y1 and it says, hey, go evaluate Y1 with the input being 36. When you hit enter, you get it 32.509, which would be, if I round it correctly, would be 33 kilograms. Okay, now let's look at this one. For each of the preferred grip strengths, decide whether you would use extrapolation or interpolation to approximate the value of the corresponding non-grip. Well, let's see. Extrapolation means it's outside of your data set that you have. Interpolation means it's inside. Okay, so let's kind of look at our data, I guess. Okay, move this around down here. 4540, what's the lowest? Okay, I gotta write the lowest there. So that's a 32. No, got a 26 there. What's my highest on the top row? 53. Okay, what's this one? 21, 20. Got a 20, and then what's my highest one? 54. Okay, so basically all my data that I've got on my group preferred is between 20 and 54, right? So, okay, so if your data is in between these, then that would be an interpolation. Okay, enter in between your data, right? Extrapolation would be outside of that. So 57 is outside, so it'd be an extrapolation. 19 would be outside extrapolation. 36 would be in interpolation, and then 39 would be that. So that gives you how you do that. Those are just big words for, is my data inside, my measurements, or is the data that I'm wanting outside of it, which means you'd extrapolate. Okay, very last one, 1.6. So let's kind of look at it. It says the average life expectancy in the U.S. Has been rising steadily over the past few decades. Yay, thanks to modern medicine and the good Lord. But as shown in the table below, let T be the number of years since 1920. So we're resetting the clock, right? So that's 0, that's 10, that's 20, that's 30, 40, 50, 60, and 70. Make sure that they're going up. They may jump some, so 30, 40, 50, 60, 70, 80, 90. Sometimes they have a tendency to do that, and you'll be left with trying to figure out what the heck happened. So again, we're going to type this in and get my life expectancy, and then it'll say what is the life expectancy in 1952. Now 1952, if you're going to find your, that'd be so we're going to put that there. 1952 is 32 years from 1920, right? So the T is going to be 32. All right, so let's do it. Let's clear this. Again, we're going to do a regression. So let's go second plus number 4. Clear all my list. Hit stat. Enter. Let's go back to grab my list real quick. We're going to go 0, enter, 10, enter, 20, enter, 30, enter, 40, enter. Oh, that's 4. You got to go 40. 50, enter, 60, enter, 70. Okay, boom. L2 be 55.7, 57.9, 61.2, 0.2, 63.9, 67.7, 69.6, 72.4, and 75.5. Enter. Alright, so everything lines up. Alright, so stat arrow number 4. Again, we're going to store this in Y1 because we're going to do some analysis. So as far as arrow to the right, enter, enter. That keystroke, folks, is something you need to make sure you memorize because you'll use it extensively throughout this class. There we go. Now we're going to do this, and I'm going to pull this over here. Okay. So I've got it to 4 decimals just because that's what I had last time. So 0.2858t time, right? This function of t, not x, plus 55.4833. Okay, so that's straight from the regression. Now, what would it be if? What would the output be, or life expectancy be, if you in 52? So in 52, t is 32, right? So we'll go in here and we'll hit, hey, let's do this again. Let's go second mode. Let's go vars arrow, enter, enter, and let's go 32, and then hit enter, and it would be 64.6289. Did I get that right? 64.62. There. Yeah. All right. So, ladies and gentlemen, this concludes Part 3's video of Section 1.6, Chapter 2.